Hey friends, what's up? Welcome back to my channel. In today's video, I'm gonna show you how to encrypt your string, or it may be a file, or again you can decrypt your string and files. Okay, so let's get started. I'm just creating a new process, okay, in UiPath Studio. So I'm giving the name here encrypt underscore decrypt. Okay, and just copy this, and you can provide the better description. I'm just copy pasting the same thing. You can provide, if you are working in a live project, you must provide a better description here. Okay, so UiPath will create a process for us. Okay, so it's restoring dependencies. Okay, so in this process I will show you each and everything what we are going to do, and how to encrypt the data, and how to decrypt the data. Again, back to the UiPath. Okay, so let's get started. So I'm just clicking on my main.yaml file. Okay, so first of all we need to add dependencies, because of by default uh, dependency is not added by the UiPath. So I'm just clicking on manage packages. Okay, and then click officials. So once you click on official, it will give you the all the official officially released packages. Okay, so type crypt here, so it will give you the cryptography.activities. Okay, so I have already downloaded. Okay, so I'm clicking on this again. You can add and install this activities. You know how to install and save the crypto activities. Okay, so you know how to add the dependencies in your processes. Okay, this is how we have added here. Okay, so cryptography.activities has been added to your dependencies. Okay, so I'm already inside the main workflow. Okay, so here what I'm trying to do, I will just bring flowchart here. Okay, flowchart is very easy to use, and it is very helpful while you are dealing with the multiple sequences. Okay, double click on it, and then again I will bring one more sequence here. First I will show you uh, encryption. Okay, encryption underscore string. Okay, oops, something went wrong. Okay, this is how, and I'm just selecting as a start node, come to the inside the sequence, and here what you need to do, you have to go to the activities panel, and you have to type crypt here. So you will get all the cryptography options available here. So what I'm trying to do, I'm just bringing this encrypt text here. Okay, so here I'll tell you what is all about. Okay, in the text is meant for whatever text you want to encrypt. Okay, let's say I will provide some random text like this is my YouTube channel. Okay, colon practicing RPA. Okay, and key you can provide anything. So I'm just putting 123 here. Okay, so we need to provide output variable as well, so where we will store this encrypted string. So put control A, on the fly it will create your variable. Okay, and so you can provide and output underscore encrypt. Okay, just hit the enter, it will create automatically your variable. Okay, and I want to put two things here. I want to bring one message box and along with write line activity. Okay, so I will put the variable here, output encrypt. The same variable I will put here as well, output encrypt. Okay, this is how we have done the encryption part here. And similarly, I will bring decrypt text as well here. Okay, so the text which we have encrypted, so I will put the same variable where we have encrypted text here, and key I will provide the same key. If you won't provide the same key, then it won't be able to decrypt your text. Okay, so this is how we did it, and we need to create the decrypt output variable as well. Press the Ctrl K, output underscore decrypt. Okay, similarly I'm bringing again message box and write line activity. Okay, so I will provide the same variable, output decrypt. Okay, output decrypt. Okay, so let's debug this thing. Let's see how UiPath encrypt or decrypt our text string. I will tell you in some time what is AES here, what kind of algorithm we are using while encrypting or decrypting the text. Okay, so here we have got the encrypted string here. Click on OK and see the encrypted text string which we have supplied to the decrypt text. The same has been decrypted into the original string. This is how we do encryption and decryption in the UiPath Studio. Now I will tell you what exactly it is AES DES algorithm, and there are 5 by default algorithms provided by the UiPath through which you can do your encryption and decryptions. Okay, first of all I will tell you what is encryption, what UiPath uh, is giving to us. Encryption is the practice of scrambling information in the way that only someone with a corresponding key can unscramble and read it. Encryption is a two-way, right? Encryption is a two-way function, whereas hashing, if you see on the activities panel, there is hash file with key, hash text with key options or key activities are available. I'll tell you what is hashing. Okay, so let me complete this encryption first. So encryption is a two-way function. When you encrypt something, you are doing so with the intention of decrypting it later. Okay, encryption always intends to decrypting it later, because of whatever we are encrypting, we are going to decrypt the data, right? This is a key distinction between encrypting and hashing. Okay, to encrypt data you use something called a cipher, which is an algorithm, a series of well-defined steps that can be followed procedurally to encrypt and decrypt information. Okay, now comes to the algorithm part. So these are the modern encryption algorithms. AES stands for Advanced Encryption Standard, originally called Regendale. Okay, this one is non-FIS Regendale. It is the specification for encryption published by the National Institute for Standards and Technology, that is the NIST, back in 2001. It puts plain text through a number of transformation rounds determined by key size. Each round consists of several processing steps. Let's not stray too far into the weeds of this one. AES is a common algorithm, right, with SSL and TLS on the web. It replaced the data encryption standard, that is our DES. Okay, and that was created in 1997, long back. Okay, so actually AES replaced our DES. If you want to use DES, that's fine, otherwise ES works well. Okay, so now coming to the third algorithm, that is the RC2. Basically RC2 is a 64-bit block cipher with keys of variable length. It is designed by the Ron Rivest for RSA data security, and it is used widely now, most notably in the secure messaging standard, right? In long back 1997, RC2 was published as an internet draft only. The model for cryptanalysis in this report is the standard one for block ciphers, right? So where it was assumed that attacker has access to a black box which encrypts any chosen input of decrypts any chosen output using RC2 with a secret. Randomly chosen key is the key of RC2. Okay, RC2 is not a faster cipher and an optimized version of DES, right? So that's why by default AES we were using RC2. RC2 is not a fast cipher, right? Okay, so coming back to our fourth algorithm here, Regendal non-FIS. I'll tell you what is the meaning of FIPS here. FIS is Federal Information Processing Standards. Okay, so if your algorithm is FIS compliant, that's good. It is not compliant, that's why we have UiPath has written Regendal non-FIPS, because of it is not an FIPS compliant thing. Okay, and the Regendal algorithm was created by the Belgian cryptologist Vincent Reisman and John Damon. Okay, so from whose surname the word Regendal is derived, right? Regendal has its origin in Square, an encryption algorithm previously designed by the pair, but was intended to improve upon that earlier attempt in accordance with three guiding principles, let's say. Resistance to all known attacks, speed and compactness of source code on a number of computing platforms. Simplicity of design is the main phenomena of Regendale algorithm. Okay, so Regendale is a symmetric key encryption algorithm basically. So that's constructed as a block cipher. It supports key sizes of uh, 128, 192, and 256 bits, with data handling taking place in 128-bit blocks. Okay, so this is the some basic knowledge about the algorithms. Let me complete this last one as well. Triple DES. Okay, triple DES basically comes with two variants, like 2 key and 3 key. Before using 3 key triple DES, user first generate and distribute a 3 DES key, that is the K, which consists of 3 different DES key like K1, K2, K3. This means that the actual 3 triple DES key has a length of 3 multiplied by of 56, right? That is a 168 bit only. So conclusion, if you conclude all 5 algorithms here, so if you found that AES is the best algorithm which is good as far as encryption and decryption is concerned, you can use based on your scenario which algorithm will suitable to you. Okay, so let me show you how to encrypt and decrypt a file. Okay, so I'm coming back to my flowchart here. So I will bring one more sequence here. Okay, so what I will do here, I will rename this sequence first. Oops, something went wrong. Okay, so what I will do here, I will type encryption underscore file. Okay, so we'll come to the activities tab. Okay, so here what I will do, I will bring encrypt file. Okay, and I will bring in decrypt file as well. So I'm demonstrating you encryption and decryption simultaneously. Okay, so what I'm trying to do here, I will provide the input path for our encryption file activity. So I will create one file here. Just now I will create. Okay, on the runtime as well you can give any file, right? So I will provide the name in encrypt.txt file. Okay, so I will provide the path for this file, and key I will give the you can provide anything whatever you want to put as a key. Okay, and output path I will provide the same path here. Okay, so I will provide the file name encrypted underscore file dot txt. Okay, so we are done. Okay, so I'm clicking overwrite here because what will happen once encryption is done, the moment you go for the next cycle, it will not allow you to encrypt because the file is already exist. Okay, so when the moment you hit the overwrite, then it will overwrite your file again. Okay, so input file I will take from the output file. Okay, so why it is not appearing here? Okay, because encrypted file is not there. So what I will do here, I will comment or disable this activity here, and I will debug first. Oops, I did not set the sequence as a starting node. We will get the error. I'm just stopping this, and I'm going to flowchart label. I'm putting this as a, uh, set as start node. Okay, now I will debug. So it will create encrypted file in the destination folder where we have provided. Okay, I'll show you here. Just refresh your project. Encrypted file.txt will get. Okay, see the encryption has been done in our file. Okay, so I will just close this, and now I will enable this activity here, and I will provide the path encrypted file, and the key you will have to remain the same key. Okay, so you will have to provide the same key here. So I'm just copying the same key while we have provided at the time of encryption. Okay, so output path I will create the file name decrypted underscore file. Okay, dot txt. Okay, so let me debug again. Let's see what happened. Okay, so let me refresh my project. See, we have received the decrypted file here. Oh, what happened? Encrypted file.txt. Okay, encrypt.txt. Oops, I did not return anything. Okay, so I will write it down. This is practicing RPA YouTube channel. Okay, so I'm just saving this file. save it, and again debug it. It will process. And okay, so we are getting the file already exists, parameter name, output path. Okay, so this is the error which I was just talking about earlier. So if you overwrite, then it will not give you the exception. Okay, so I'm just clicking on overwrite, just debug again. It will not throw you the exception now. Okay, it will execute and complete the process. Okay, so first I will see the encrypted file here. This is the encrypted file. Okay, and what is the decrypted file? This is a practicing RPA YouTube channel, and if you see, this is our sample file. This is practicing RPA YouTube channel. This is how you can do the string encryption and decryption, and the file encryption and decryption as well. Okay, so we are done with both the activities. Okay, so I will do one more thing here. I will give you the little idea about the hash file. So before doing that, I will just bring one more sequence here. I will set as a start node. We will go to the inside the sequence, and I will bring hash text with key. Okay, so here if you see, there are so many algorithms are available. Okay, hash key with key, you can use it. Okay, so I'm deleting this one. I'm putting hash text. Okay, so here if you see that SA1, if you have done this client security hash project that in the RPA community, or you have done this as part of your advanced certification, SA1 was there. Okay, so there are 4 options available here: SHA 256, 384 and 512. Okay, so you can use any algorithm here. Okay, so text you can provide anything here. So I'm just putting like this is UiPath Studio. Okay, so we are getting error. Okay, so we have to create an output variable. Just press control K. Okay, and provide your variable name. So I will just putting output underscore hash text. Okay, just hit the enter button. It will create the variable on the fly. Okay, so right now you can test this activity as well. Okay, so why if we are having an encryption or a decryption in UiPath, then why they have provided the hashing? Do you know what is the difference between encryption, decryption, and hashing and salting? So there are so many variants available here. Okay, so I just want to show you. Okay, so let me put down here. So I will take one write line activity. So output hash text I will provide. Okay, and debug again. Let's see what comes to the output. See, this is the hash key. Okay, whatever we have written that this is UiPath Studio. So UiPath Studio has converted into the hash text. Okay, so I'll give you the brief idea about the hashing here. So hashing actually is the practice of using an algorithm to map data of any size to a fixed length. Okay, so this is called a hash value, or sometimes hash code, or maybe hash sums, or even a hash digest. Okay, so whereas encryption is a two-way function that I have already told you in the early phase of this video, hashing is a one-way. Encryption was two-way function and hashing is a one-way function, right? While you are doing encryption, you are intended to do the decryption also. Okay, so now here what we are saying that hashing is a one way We are not intended to do the reverse process of hashing, right? While it's a technical possible to reverse hash something, the computer power required makes it unfeasible, right? So hashing is a one way. Now, whereas encryption is meant to protect data in transit, hashing is meant to verify that a file or piece of data has not been altered, that it is authentic, right? In other words, if you say, it serves as a checksum. Okay, let me tell you some more examples here how it works. Each hashing algorithm outputs at a fixed length. Okay, so for instance, you may hear about SHA-256. That means that the algorithm is going to output a hash value that is a 256 bits, right? And if you see here, uh, SHA-384, SHA-384 is going to output a hash value that is a 256 384 bits. Okay, similarly, the SHA-512 will give you 256 bits hash code. Okay, so usually represented by a 64 character hexadecimal string. Okay, so every hash value is unique. If two different files produces the same unique hash value, this is called a collision and makes it the algorithm essentially useless. Okay, so it always be a unique value. Okay, so there will be no similarity as such. Okay, so let's say you want to digitally sign a piece of software and make it available for download on your website. To do this, you are going to create a hash of the script or executable you are signing, right? Then after adding your digital signature, you will hash that. Okay, so following this practice, the whole thing is encrypted so it can be downloaded. Okay, so when a customer downloads the software, their browser is going to decrypt the file, then inspect the two unique hash values. The browser will then run the same hash function using the same algorithm and hash both the file and the signature again. If the browser produces the same hash value, then it knows that both the signature and the file are authentic. They have not been altered, right? If it is not so, the browser issues a warning to the user, right? That's how actually code signing works. Just simply remember, no two files can create the same hash value. So any alteration, even the tiniest tweak, will produce a different value. Okay, so this is how hash algorithms works. Okay, so you can see here that SHA-1, MD5. MD5 is another hashing algorithm made by Ray Rivest that is known to suffer vulnerabilities. It was created in long back 1992. Okay, so currently MD6 is in the works, but as 2019 Rivest had removed it from NIST consideration for SHA-3. Okay, so SHA stands for Security Hashing Algorithm, and it's probably best known as the hashing algorithm, right? So you have already used this SHA-1 algorithm while completing your client security hash project on UiPath Academy, right? And right, Repemd is also a algorithm here, a family of cryptographic hashing algorithm with a length of 128, 160, and 256 and 320 bits. Basically, it was developed under the framework of EU's project right by Hans Daubertin and a group of academics in 1996. It's 256 and 320 bits variant don't actually add any additional security. They just diminish the potential for a collision, right? So in 2004, a collision was reported for RipMad 128, meaning RipMad 160 is the only algorithm from this family worth its salt. Okay, so this is how you can use the algorithm here. Similarly, you can use the other files as well. I have used hash text here. You can use hash file as well. Similarly, what we have done in the encrypt encrypt file. Okay, so you can try at your home. If you are facing any issues, just comment me out. I will show you how to use hash file and with key and hash text with key. Okay, so if you like my content here, so please do like and subscribe. And until now, happy automation. Thank you.